Good afternoon. Welcome to day 4/5. So today we are going to be looking at how to conduct an experiment so that we can test how stretchy our bungee is. And really what we're trying to kind of get at is figuring out the equation or the math model for the elastic energy. So how do we figure out how much energy is stored in our bungee cord? All right, so kind of getting into that type of stuff, we're going to be looking at a lab. And so first off, your research question is how does the stretch of the spring, or bungee cord in this case, affect the elastic energy stored in it? And so we're going to be following along with the lab here. So we can start off with the lab. Again, by now you should have typed in your name here, of course, performed by. And then we want to try and answer this question. So how much is the string or the bungee going to be stretched if it gets 30 joules of energy? And again, it's a wild guess, right? We don't expect you guys to have the right answer. We don't want you to go back and change it later. We just want a wild guess. 30 joules of energy, how much do you think it's going to stretch? You guys can go ahead and fill that in. All right. The next part is important in terms of making sure that you guys are at least consistent with your responses here, right? We want these two things to match up. So in words, we want to answer this question: how does the stretch of a spring affect the elastic energy stored in it? Now, for me, I always start with the words because I think it's easier, and I always start the words the same way, right? So increasing the stretch of the spring, what's that going to do to the elastic energy? Right? So if we increase the stretch of the spring, the elastic energy will, and then what do you think? Do you think it's going to increase? Do you think it's going to decrease? Do you think it's going to stay the same? So as you stretch the spring more and more, is it going to store more energy? Is it going to store less energy? Or is it going to store the same amount of energy? The key here is that whatever you put for your words, it should be matched by this graph. And again, you can just double click the graph to edit it, draw your line. If you said increasing, you should have a line that increases. If you said decreasing, you should have a line that decreases. If you said stay the same, again, a line that stays the same. Again, think back to the different types of patterns that we have. Right? We've got 4 different patterns that you guys can look at and use and think about. Once you finish that, again, we'll continue on. We've got a system analysis diagram here. So again, this is very similar to what we've been doing in the last couple of days in class. So you'll want to just open this up and think to ourselves, okay, at position 1, at the very start here, it's not stretched yet, right? It's just sitting up here. What type of energy do you think it has? And you can either drag these boxes over to the spots, or you can just make your own boxes. I'm perfectly fine with you guys just making your own boxes. Either way, up to you. We also have, the arrows for transfer, right? Transferring the energy over. And we have the arrow for transform. Again, you can make your own, or you can use these, copy and paste, and put them wherever you need them. Again, making sure that you're filling in what types of energy it starts with. How does that affect the total energy? At position 2, what types of energy does it have? How does that affect the total? What does the total look like before and the total look like after? Think about those types of things as you guys are filling this in. Next, we get into the actual lab here. So the actual lab, we're going to collect some data and we're going to record it into our data sheet. And The data table is included, right? So we have that, that we can find it in the lab. When we're done with this, what we're going to want to do is we're going to want to paste this back over into our lab template, right? We want to paste that data table back there. The reason why we're doing it in here is because we're going to be able to code some stuff and make our lives a little bit easier. First thing we can do, we need to, of course, type in what the value is for gravity. And so you can just type in our 9.8. That's what gravity is here on Earth, 9.8 meters per second squared. If at any point you guys are struggling, right, you can go to this video link and click that to watch a tutorial for how to do some coding. But I'll go through some of the basics pretty quickly together. Don't forget our qualitative and our quantitative data, right? So don't forget our controls. What are we keeping the same? Don't forget to make observations while we are conducting the lab. So for the lab, what you're going to have is you're going to have a bungee cord. And on that bungee cord are 2 paper clips. And you're going to want to make sure that you take note of what color those paper clips are, because that's the first question that it asks you right here. And so you're going to put red, green, or red, red, or whatever colors are on your bungee. And that way you can make sure that you can use the same bungee again and again and not have to throw out all of your data and start from scratch. So it's really important that you know which colors your bungees are. You could even put that into that quantitative data if you want, just kind of making that observation of like, hey, I noticed that the colors are blah, blah, blah. All right. For the actual lab, what you're going to be doing is you're going to be holding the bungee at a place where it's not stretched out at all, right? So we don't want there to be any stretch in the bungee. And the easiest way to do that, and of course I'll demonstrate it in front of the class, but the easiest way to do that is to basically lift up the mass that's on the bungee, so that the bungee just starts getting loose, right? And once it starts getting loose, that's how you know that you're at the point where it is starting to kind of not hold any of the weight of the mass. Now, you don't want to lift it all the way up, right? You don't want a huge extra space in your bungee. You just want it to be so that it's not supporting the mass. At that point, you're going to go ahead and let it go, and you're going to see how far it pulls the bungee down. And of course, that means that you're going to need to record your starting position. You're going to need to record your mass that's on your bungee. And you're going to need to record your final position. How low does it get? And to do that, you're going to need to take video. And so here's an example of my video that I took. You can't see the start on here because it's up off of the screen, but it's more important to get a video of the final position. And this is, of course, with 300 grams or 0.3 kilograms. So we can kind of go ahead and see what happens here. So it's being held way up there, and then of course it's being dropped. And we can see how low it gets, right? And that, we can go ahead back to the video, we can pause it, we can slow it down as needed so that we can find the exact lowest spot that it gets to. And that will be our final height. Again, notice that I have 0 at the ground so that everything is measured up from there. When we fill in our data table, again, we just be able to put in our 300 for our mass, which converted to kilograms, divide by 1,000. So that would be 0.3 kilograms. The starting height was 0.9 something, I don't know, 0.9 exactly, never mind. And then the ending height, again, these are in meters, so make sure that you're converting your centimeters to meters. and the ending height was, I don't know, somewhere around 0.42 or something like that. Not a big deal there. Again, you guys aren't going to put these numbers, you're going to put your numbers in. So now we can get to some of this coding stuff. Now, starting gravitational energy, we know from the other day that gravitational energy, the equation is mgh, or mass times gravity times the height, or in this case, the initial position. So to code this, I'm going to go ahead, again, up here is where we're going to put the code, right? So we click there, click up to the top, and we're going to go ahead and put in equals. That's how you always start a coding. Now mass is this box right here, so I'm going to click that box, and it's telling me what the mass is. That's fine. Times, so that's shift 8 to get that little asterisk in there, m times g, so our g value is this 9.8, times our height. And since we're looking at starting energy, we're looking at starting height. Perfect. So now we've got that. We can hit enter so that it stores that code. Great. We can go ahead and do that coding again for all of the other starting energies as we go. One thing to make note of is that a lot of times people will just click this little circle here and drag down, and that completes the code, but there is a problem. That if we look at the code, what happens is it's taking the mass and the height, that's perfect, but it's not taking the value of gravity anymore. It dropped down. Just like it dropped the mass down and the starting height down, it dropped this value down. So there's two ways to fix that. One would be just putting in 9.8 for that B4 value, right? That's not a great solution. The other solution that we can go to is in our initial code, if we put a $, and then when we drag down, let's see, did not work. That's because I put $, in the right spot, but yeah, okay, see, perfect. So now we've got, it's collecting this value here, which we don't have anything in there yet. It's collecting this value here, which we don't have, picking the same gravity value. It's still picking 3 because 3 is locked in using that $. So that's really nice for us. All right, next one we want to look at is ending gravitational energy. And again, we're going to start off with an equals. We're going to go ahead and click our mass, shift 8 to get the multiply, our gravity, shift 8 to multiply, and our ending height this time. So again, we can check to make sure that the boxes that we want are selected, and they are. Don't forget we can do that $ trick so that we can lock in the 3, and that way when we paste that down, it saves that value and it uses the correct values here. Oh, and it asked me something and I was not paying attention. All right, so we want to drag that down. We do not want it to automatically lock stuff in for us. We already did that ourselves. We can always double check. If you click up in the function box at the top, you want to make sure that it's selecting the right things. Mass times gravity times the ending height. Perfect. Enter. Make sure that you don't click something by mistake. All right, so that tells us our initial energy was 2.6. Our final energy was 1.2. All right, where did that energy go? Well, that energy had to go into the elastic energy. So next thing we want to code is the distance stretched. Well, the stretch distance is just the starting and final height subtracted from each other. So we're going to go ahead and hit equals starting height minus ending height, enter, and it again, calculated that for us. We can drag that code down so that automatically, we don't want their suggestions. Their suggestions are never good. We're going to click in the function box at the top just to make sure that it's pulling the right thing. Starting height minus ending height. Perfect. So that's how we know we did everything right. Hit enter to save that. Last but not least here, again, that elastic energy. So we're going to click at the top, hit equals. Well, how do we know how much elastic energy there is? We haven't done the equation for it yet. But that's okay because we know that the change in gravitational, where did that energy go? That energy went to elastic. It went into the rubber band. So we can just subtract these and figure out how much energy there must be stored up in the rubber band. So again, we're just going to subtract these. So starting energy minus ending energy, enter. So we started with 2.6 units of energy. At the very bottom, 1.2 of those were gravitational still. The other 1.4 was elastic. So that's where our energy went. All right. Now you guys will actually do your lab, calculate your values here. Again, different masses would be useful. The same mass a couple of times to make sure that you get some good values makes sense as well. So again, you're going to want to collect some different values here so that you guys have some different distances stretched, some different elastic energies that you will then be able to graph in Desmos. So I will go ahead and undo all of these things so that I can post that for you guys. Again, there's a troubleshooting video you guys can watch. If you guys are struggling with the code, feel free to take a look at that. And as always, we again want to take that and paste that stuff into Desmos so that we can graph that. Again, remember that the graphing for Desmos stuff, the steps are all at the front of the class, above the whiteboard. Distance, energy, fill in those with your values. Move the C slider so that one of the lines fits it as best as possible. Again, figure out which line you think fits best. Eliminate the ones that don't. Write in your mathematical model with words, right? What does EE stand for? What does C? There's a number. What is that number? What does D stand for? Again, if you guys are ever kind of getting stuck figuring out what those things are, look back at your data table, right? Your data table is going to tell you what those E and D things are. When you think that you are done with your Desmos graph, right, make sure that you guys check it with somebody. Because once you close it, you're going to have to put in all that data again. You're going to have to do everything from scratch. So have somebody double check it. Did you write in the math model correctly? Is your line of best fit an actual good line? Right? Make sure that you guys are getting some feedback before you copy it and paste it. And then conclusion, we'll work on with day 5. Again, making sure that you guys are looking at the rubric if you want to make sure to maximize your possible points. Do not forget your research extension question. Do not forget your qualitative and quantitative data, right? People always forget those things. So make sure that you guys are not forgetting, skipping any of those steps. All right. Yep, and then the slides will kind of step you through any of those things that if you guys are getting stuck, if you guys need help. Again, it's kind of got a sentence frame here to help out. As the stretch of the spring increases, Will blank, right? Will it increase? Will it decrease? Now that we know some of the patterns, you can include what pattern you think it's going to fit into and why. Again, some pictures of the bungee and the setup for the bungee, system analysis, and so on. A couple of tips when doing the lab. Make sure that however you are fastening the top of the bungee, that it is not moving, right? If you are holding on to it and your hand moves, that's going to throw off all of your numbers when it comes to doing these calculations. So you really want to make sure that you are not moving that top anchor point. So whatever you're using to anchor it, make sure that it is not moving. If you use masses, again, make sure that your masses are not too heavy. If you use something that's too heavy, it's going to stretch too much, right? If it hits the ground, obviously that's going to be a problem as well. So do a test, right, to figure out roughly where that final position is going to be. And then make sure that you guys are recording video so you can slow it down. You can find that exact lowest position. Make sure that your measurements are consistent. Right? Are you measuring from the end of the bungee or are you measuring from the bottom of the weights? Doesn't matter as long as you stay consistent with that. Don't forget to paste your data table back in. Don't forget to paste your Desmos back in. And feel free to use the conclusion sort of reference if you guys want when writing the conclusion. If you have any questions, let me know.